Welcome to the lecture on rapid sand filtration. I'm Dr. Audrey De Cruz, Professor and Head, Department of Public Health Dentistry, A.B. Shetty Memorial Institute of Dental Sciences. The previous lecture has already discussed about the slow sand filtration, which is a part of the large-scale water purification. This lecture will be concentrating on the steps in the rapid sand filtration. Before going into the filtration process, a brief note about the rapid sand filters. Rapid sand filters are also called as mechanical filters. The first rapid sand filters were installed in USA in the year 1885. There are two types of rapid sand filters. One is the gravity type and the second is the pressure type. So gravity type, the example is the Peterson's filter. The water percolates down through the rapid sand filtration by the use of the natural gravity. In the pressure type, pressure is applied by a constant flow of head of water. An example to the pressure type of filter is the Candice filter. Let us discuss the steps in the rapid sand filtration. There are 5 steps. The first one to start is the coagulation, next rapid mixing, flocculation, followed by sedimentation, and finally filtration. The first step in a rapid sand filtration is coagulation. Here, the raw water is treated by the addition of a chemical coagulant such as alum. Now, the dosage of alum varies depending on the turbidity, the color, the temperature and the pH of water. The dose may vary from 5 mg to 40 mg of alum per liter. So when you add a coagulant such as alum to untreated water, the coagulant absorbs onto the impurities as it is shown in the figure there, reducing the impulsive charges and forming flocks. The added alum is rapidly mixed into a mixing chamber, which is the second step in a rapid sand filtration. The treated water is subject to violent agitation in a mixing chamber for a few minutes, which allows quick and thorough dissemination of the alum throughout the bulk of water. The next step is flocculation. Flocculation is nothing but slow and gentle mixing or stirring of the treated water in the flocculation chamber for about 30 minutes. So the tank consists of paddles which rotate at a RPM of 2 to 4 per minute. The slow and gentle stirring results in the formation of aluminum hydroxide or alum flocks. The water now moves into the sedimentation tank and is ready for the next step of rapid sand filtration, that is the sedimentation. Here in the sedimentation tank, the water is detained for 2 to 6 hours. The alum flocks which have formed due to the flocculation process, they settle down due to their weight and also due to the gravity. Along with the impurities, bacteria also settle down. Precipitate is removed from time to time without disturbing the operation of the tank. Tank should be cleaned regularly. If not, it can lead to breeding of various organisms such as mollusks and sponges. The sedimented water is now set for filtration. The partly clarified water is subjected to rapid sand filtration. So whichever alum flock that was not removed by the sedimentation process in the sedimentation tank is now held back by the sand bed of the filters. The oxidation of ammonia also takes place. The picture depicts a cross section of a filter bed. The total surface area of the filter bed is about 80 to 90 meters square, and sand is the filtering medium. The sand bed here is made out of various particle size and it is in a form of a graded bed. The effective size of the sand particles range from 0.4 to 0.7 millimeter. The depth of the sand bed is 1 meter, and below the fine sand is the layer of graded gravel, which is about 30 to 40 centimeter. Now, the graded gravel meaning to say that the particle size of the gravel is of various sizes, and this helps in better purification or filtration of the water. The depth of water on the top is 1 to 1.5 meter, and the rate of rapid sand filtration is 5 to 15 meter cube per meter square per hour. As the filtration proceeds, the suspended impurities and the bacteria clogs the filter bed. The filters soon become dirty and they begin to lose their efficiency. This is called as loss of head. Now, when this loss of head reaches around 7 to 8 feet, the filtration process is stopped. The pressure increases, so the pressure needs to be released, and then there is a process called as backwashing for cleaning of the filters. Backwashing is nothing but cleaning of the filters, which is done either weekly or whenever the loss of head exceeds 70 to 80 feet. So, washing is accomplished by reversing the flow of water through the sand bed, which is called as backwashing. If you see in the figure below, the green arrows on the left hand of the picture denotes the regular filtration process. So, it is according to the gravity from top to down, whereas on the right hand side of the image is the backwashing process, wherein you can see the blue arrows where the water is reversed. So, there is reversal of water flow, that is just to dislodge the clogged filter. How long the backwashing process goes on? It is till you get the clear sand on top, which is visible, and clear water flows out of the top portion of the filter. So, when the water becomes clear and the sand is visible, the backwashing process is stopped, and then the regular filtration process is carried on. Coming to the advantages of rapid sand filtration, it can deal with water directly, and there is no preliminary storage that is required, as the case in case of the slow sand filter. The filter beds occupy less space. Filtration is rapid, around 40 to 50 times than a slow sand filter. The washing of the filter is easy. It just requires the reversal of flow of water, and there is more flexibility in operation. However, the major disadvantage is that there is a lot of technicality that is involved and skilled manpower is required. This slide shows the difference between the rapid sand and the slow sand filter. A rapid sand filter occupies very little space, however, a larger space is required for a slow sand filter. The rate of filtration is 5 to 15 per meter cube per meter square per hour in case of a rapid sand filter, whereas a slow sand filter, it is 0.1 to 0.4 meter cube per meter square per hour. The effective size of a rapid sand filter is 0.4 to 0.7 millimeter. In case of slow sand filter, the particle size of the sand is still smaller, that is 0.2 to 0.3 meter. Chemical coagulation is required as a preliminary treatment in case of rapid sand filtration, whereas plain sedimentation or storage is sufficient in case of a slow sand filtration. The cleaning of the filter in case of rapid sand is done by backwashing, whereas in case of slow sand, it is done by manual scraping of the sand bed. For the operations, you require highly skilled manpower in case of a rapid sand filter, whereas in case of a slow sand filter, less skillful manpower is sufficient. The turbidity in both the sand filters is good, And the removal of color is good in case of rapid sand filter, but fair in case of slow sand filter. The removal of bacteria is 98 to 99% in case of rapid sand filter, but is more efficient in case of slow sand filter, which is about 99.9 to 99.99%. So to summarize the entire lecture, there are 5 steps in case of rapid sand filtration. So the raw untreated water first passes through the phase of coagulation, where the coagulants are added, followed by rapid mixing, then slow mixing by the flocculation, a sedimentation process wherein the heavy particles along with the impurities and the bacteria settle down, and then finally the process of filtration. Thank you.